Hello everyone. Welcome to the solution of LeetCode problem 239 named sliding window maximum. In this problem, we are given an array of integers and there is a sliding window of size k which is moving from the very left to the right. Now, we can only see the k numbers in the window. Each time the window moves right by one position. Now, we have to return the maximum sliding window. Suppose in the first example, the array contains 8 elements, which is 1, 3, minus 1, minus 3, 5, 3, 6, 7, and the window size k is 3. So here, for the first window, 1, 3, minus 1, the maximum element is 3. For the second window, 3 minus 1 minus 3, the maximum element is also 3. For the third window, minus 1 minus 3, 5, the maximum element is 5. Similarly, for the next successive windows, the maximum element is 5, 6, 7. Now, I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Now the problem is, we have to find the maximum element for each of the window. Now here, in this problem, or in this test case, the value of k is 2. The value of k is 3. Now the window size is 3. So for the first window, the maximum element is 3. Now for this window, the maximum element is 3. For this window, the maximum element is 5. For this window, the maximum element is 5. Similarly, for this window, the maximum element is 6. And for this window, the maximum element is 7. So we have to return 3, 3, 5, 5, 6, and 7. Now, the question is, how can we solve this problem? And the basic intuition is, as the sliding window technique mentioned in the problem statement, you can solve this problem by using the sliding window, but I am trying something different approach. Basically, in any of the problem, if we have to find the maximum, most of the cases, those kind of problem can be solved using the priority queue or by using the maximum heap. Before proceeding to the problem, we have to understand what priority queue is. Priority queue is just a queue where the element will be presented, or the maximum element will be presented at the top, and the smaller element will be presented at the bottom. And if we pop the element, we will pop from the top of the priority queue. Now, we can store a pair of values into a priority queue. Suppose we can store one pair, which is 3, 2. Now, if we store another pair, 3, 1, this 3, 1 pair will be beneath the entry 3, 2, because though the first value 3 and 3 is equal, then it will compare the next value. So next value 2 is greater than. So this 3, 2 pair will be the top of the priority queue, and 3, 1 pair will be the bottom of the priority queue. This is the basic intuition of the priority queue. Now, the algorithm is pretty simple. We have to simply iterate from left to right and insert the pair A of I and I into the priority queue. Now, suppose for this one, we have to store 1 and 0 as a pair. Now, for this 3, we have to store 3, 1 as a pair, where 3 is the value and 1 is the index number, and it will above the value 1 because of the maximum priority queue. Now, for minus 1, we have to store -1 and 2 at the bottom of the priority queue. Now, our window size is becoming the value of k. So we have to store the maximum element, which is 3, and which is the top of the priority queue, into a vector. Now we are at this element -3. So we have to store -3 and 3 as one of the entry, and it will be at the bottom. Now we have to check whether our priority queue's top element is in this range or not. Because if our window size is this, then we have to exclude the maximum element if the maximum element presented at this position or in this portion. But fortunately, the maximum value is 3, and which is in the current window. Okay, so far so good. So here the maximum element is 3 for this second window. Now for this third window, we have to store the value 5 and 4 as the entry. And here again we have to check whether the top element is in this range or not. But top element is not in this range, so we have to store 5 as the top element of the window. Now our window is this, which is -353. So here we have to store the value of 3 and 5 as one of the entry in the priority queue. Now again we have to check whether the top element currently belongs to this portion or not. But the top element does not belongs to this portion, so again the top element is 5. And similarly, for this window, we have to store 6 and 6, and the top element is 6. And for this last window, we have to store 7, 7 into the priority queue, and the top element of the priority queue is 7. Finally, we have to return this array. And this is how we're going to solve this problem by using the priority queue. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named max sliding window, which is a vector array and case parameter. Now we are taking a priority queue, which is a max heap of pairs. Now we are taking a vector to store the answer, and we are iterating each of the element in the array and insert them as the form of pair into the priority queue with its index number. Now, if the I is less than k-1, that means the window size is not sufficient, so we have to simply continue. Otherwise, we have to repetitively check whether the top element's index is less than I minus k plus 1 or not. If it is, we have to simply remove it from the priority queue. After that, we have to simply insert the top's elements index, the top's element value into the answer, and finally return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.